Good morning, everyone. Day 2 of RSA conference here in beautiful, rainy, foggy, typical San Francisco. 50,000 people have been around Moscone Center for the last day or two talking about cybersecurity. And one of our topics, as you guys always know, we're always talking about cryptography and its applications. And I've got Bruno, who's the president and CEO of Crypto4A, a company based out of Canada, joining me. We're going to be talking a little bit more about cryptography and some of its applications in cybersecurity. Bruno, welcome. Thanks for being here.
Thanks, James. Thanks for having me on your show.
So one of the things you constantly hear about is the need for cryptography in cyber. But you walk around this floor, I think there's maybe only a handful of companies that really deal with cryptography as a whole. What are we missing in application of cryptography in cybersecurity? Where's that going?
Well, I think you're not seeing cryptography because it's now so deep in the stack of layers of the tools we use on a daily basis that it's been around for 20 years, and most people take cryptography for granted, except for the noise you hear about quantum computing, which really suggests that some of these ingredients we've been using and components we've been using for the last 20 years are becoming coming to an edge of potentially being obsoleted by those quantum computers. Funny enough, we've taken that for granted as a tool of business. The same way you don't necessarily go and talk about your assembly compilers anymore, because we've resolved those questions many years ago. The interesting thing about the cryptography space is that it's about to be challenged on both end of the spectrum. And by that, what I mean is at the same time as we're looking at post-quantum cryptography, NIST has uncovered quite interesting phenomena having to do with entropy, which is the very bottom foundation of any security cryptographic operation. You need entropy to generate keys that can be used in cryptographic algorithms. So entropy is a thing we had taken for granted, and NIST has got some pretty interesting discovery on that front as well.
Where are you seeing, when we think of the post-quantum era of cryptography, right? I mean, the big thing is saying, hey, quantum computing could break a 512 encryption key in a matter of seconds. You're starting to see more more organizations kind of look at it and go, we don't necessarily need it. But even when you talk to people about cryptography, they often associate it with cryptocurrency and forget the encryption piece of it.
Yes.
How are you seeing companies start to look at cryptography in today's world with AI? Forget quantum, because I think the quantum piece and the post-quantum part of cryptography is going to be there. Because I think it's just going to be a larger encryption key with more authentication levels and a greater stack for authentication. But where are you seeing organizations in today's current marketplace fail in cryptography?
I don't think organizations fail in cryptography. I think cryptography has failed organization is what I think. If you think back of the history of cryptography, it's been designed initially when it came out, it was considered to be a weapon more than a tool to do business. As such, it was very heavily controlled, and its ability to use it and how you used it was highly controlled. So very much in the early days of cryptography, we kind of built an API construct around the cryptographic engines, and that API consisted of both the usage of cryptography, but you also have to impart on the users using it knowledge about cryptography operation. What's the difference between AES counter mode or GCM or those things? How often do I change my keys? And those API, for the very vast majority of time, have not really evolved. So today, if you need to use security or cryptography in an organization and you're trying to build an application, you really need to educate every single one of your application developers about the cryptographic use, the difference between the different cryptographic algorithms. Is it best to use AES or DES or SHA-1 or SHA-256? And all of that knowledge needs to be driven inside the application development focus. So I think cryptography is failing the developers because we're asking so much knowledge to be built in before you can go off and do it.
I'm going to respectfully disagree with you here for a second, Bruno. When you look at some of the latest breaches that have happened, one of the key aspects of the Marriott breach was the fact that none of the data, the passport data, the most crucial PII, was encrypted. Now, you can blame cryptography all you want for it, but encrypting data on your server, especially important PII, has been a best practice, common practice in organizations for years. Where do you feel like that kind of fail-safe is that just bad on their end in terms of just their cyber hygiene? Because I mean, Marriott wasn't the only one that have had that issue. Equifax had the same thing where data was unencrypted and just kind of randomly sitting there.
Right.
So I mean, that all falls into the cryptography space of encrypting the data you have, so that at least if someone gets it, it's encrypted, and you're going to make their life a little bit harder to get that data.
I guess what I'm suggesting is not that cryptography is to blame for everything, but using cryptography properly is a hardcore skill. And we're all complaining about the fact that we don't have enough IT personnel to deal with all the IT and the cyber and all. So add to that the knowledge of cryptographic operation and the proper hygiene about crypto key management. Right. Add that to the stack and you've got yourself a massive challenge going forward. So we've built that into the tool. We've made it really hard for your IT and your cyber experts to not be an expert in that space as well. And it causes us to have a very complex tool to use. I think we need to simplify the tool. We need to still have access to the ability to control the way we're seeing it. I guess we need to start to break the notion of using cryptography versus controlling and managing your cryptographic operations. So that's one of the techniques we believe will help us eventually get back into the game and not lose all the time.
Were you seeing kind of one of the bigger, kind of drawbacks on cryptography has been key management, right? Where are you seeing the future of key management go in cryptography?
So that I think key management is probably the most complex aspect of cryptography. Cryptography is ultimately you have a spec, you follow it, you implement an algorithm. That's doable. The use of it is also critical, but key management is really where things go wonky on you, and you have to be very knowledgeable about how often do you change the keys, who gets access to the key, how many keys need to be stored securely somewhere else, and all of that jazz. PKI, which is one technique used for managing keys, has been around for more or less 20 years. It has not really, nothing has replaced it yet. So we still have PKI. It's still likely going to be a tool for the future. But what has happened is that if you go into large organization and they have multiple applications, typically every application has got their own security staff
and
key management. And then you end up with duplication of resource. That's really expensive resource. So one of the things that we need to try and do is to get that managing and the key management aspect out of that application development cycle so we can separate that aspect of it and make it more centralized, more enterprise level kind of capabilities. I believe strongly in the fact that cryptography is here to stay. And
I agree with you. I don't think cryptography is going anywhere, even post-quantum.
Yeah, I'm not trying to push it out either.
No.
But I think we really need to get back in that game. We need to get that tool as modernized and modernize it the same way HTML has been modernized, HTTP has been modernized, everything has been modernizing, but cryptography has kind of stayed behind in terms of it's stuck in a more ARM kind of thing.
How do you explain Canada? You guys are based in Toronto, right?
Ottawa, actually.
Ottawa. Oh, sorry. Sorry.
That's okay.
I'm sorry. I didn't mean to say that, a boot. But how do you attribute the success that Canada has had in cryptography? You go back to the days it was research in motion and BlackBerry that started with really the massive scale with the BlackBerry devices, and now you're seeing a lot of the cryptography startups kind of come out of the Canada area. What's in the Canadian water that gets people into cryptography that you're not seeing elsewhere in the world?
I think, so the story goes around 1990, the internet is invented, HTML is invented.
Right.
Then the world starts to think of that as, hey, we could potentially do business on that. We need security, we need SSL. So SSL gets invented by Tahir El-Gamal. I think he was at Netscape at the time. And here in the US, I think it was under the Clinton administration, cryptography was a weapon, and NSA was trying to convince the US administration you cannot export cryptography. So the cryptography concept in the US was Cryptography is a really bad thing. We don't want to sell it off. In the same time, in Canada, our government decided that, you know what, this PKI idea, and Entrust was a Ottawa-based company that was promoting the PKI idea. We need to become PKI experts in the world. So you have Canada now sort of expanding its capabilities as a PKI expertise. Entrust as a company started to grow a network of very savvy people that were from Nortel, basically transitioning to becoming the early pioneer in the PKI space. I was in a company called Chrysalis. We did HSM, or hardware security modules, born out at exactly the same time. And what happened in Canada was we had this kind of free space to explore PKI, explore cryptography, and use it as a tool to expand this internet thing that was just evolving. Right. So that caused an ecosystem to get started. And I think it's that same momentum that has carried Canada on the world scene as a good, solid, and all the BlackBerry, the invention of elliptic curve and Certicom and those companies, all of that was born at the same time where it was possible to do it in Canada, whereas in the US, companies were in a bit of a fight from a political point of view to how we get our cryptography outside our borders. So that, I think, is one reason why Canada got a head start on that front, or going fast.
Yeah, well, it's faster.
Sorry.
No.
Just kidding.
It's okay. I'm glad you guys are leading the way in cryptography. It always works when your allies are in the same battle as you are.
Oh, yeah.
Bruno, thanks for coming by here today, man. I really appreciate it. Good luck,
here.
Crypto4A, guys. Make sure you check him out if you're here at RSA. Booth 1665. We're here at the Georgia booth. The Canadians are not far from us, so if you stop by, 1953. We've got Maddie here also with the Canadian consulate in Atlanta. So representing the love global all the way across. We're in San Francisco, RSA. We're going to be right back. Thanks for tuning in.